this is another passive infrared nipple lamp. And the interesting thing about this one, I got this one because it's got the bayonet cap lamp holder and wanted to see if the circuitry was the same. Now the last one, if you may recall from another video, had a problem that it didn't re-trigger. If you were walking around underneath it, it would always go out after a fixed time and then have to get re-triggered again. And I showed how that could be fixed. But this one does re-trigger properly, this one works. And the power in standby is negligible. Hold on, let's take a look at the current. 36 milliamps, but that's the sort of reactive power, so it's not actually at 240 volts as such. So going back round to power, I'll put this under the bench and put my hand in front of it so that it triggers. And it's supposed to be 5 watts, says just over 4. That's fine, that's okay, that's not bad. So let's unplug it and open it and see how it compares to the other one. Right, okay, we've got the LED circuit board, which is just like the other one. It does have the circuitry it almost uses a standard lamp board. I wonder why they've got the heat shrink over the capacitor. Oh, there's a wee control circuit with the 3 wires passing through that circuit board to the passive infrared module. Is that going to come out? Is it going to push out? Okay, it pushed out. Oh, they've kind of got crushed little plastic stakes in this. Hold on a second, let's see if we can hike those off. Fairly typical. It's got the LDR, it's got the pyroelectric sensor there. Nothing much more on that side. The other side has a classic. Oh, they've scrubbed the number off it. That's a bit childish. But from the pinout, you know, the actual size, I'd say it's a BISS0001. So let's take a look at the power supply here. I'm getting little flashbacks to another product here. There's a cluster of 4 diodes. I'm guessing they might be a rectifier. Except they're actually all hooked in parallel. Okay, right, tell you what, I'm just going to go and reverse engineer this. I'll be back shortly. Okay, that was a bit of a brain melter. That took a wee bit longer to reverse engineer than usual. But I have reversed engineered it and it breaks down into these modules. So the circuit board here does have these little 4 diodes, just all in parallel. And I think they may be Zener diodes, and they've just used, they can't get the bigger package maybe, or maybe it's cheaper to use these ones. The voltage I tested across them was 12 volts, and I tested it by winding the voltage up in the power supply. So the chip here is pin for pin. It's a BISS0001. It's the classic passive infrared detector. It's got a little 5-volt regulator here that converts that 12 volts down to the 5 volts locally. And then it sends a signal back to this transistor here, which turns on this triac, which turns on the lamp. So here's the circuitry. There's out of the way. The power supply for the passive infrared module is a little capacitive dropper. It's this little capacitor here with a discharge resistor, an odd value, 680k, and then a 100 ohm resistor in series with it. And then it gets a bit weird. Then it's got the Zener diodes, and then what looks like a rectifier diode, and then the capacitor. So the positive side of the capacitor at 12 volts is referenced to neutral. The passive infrared module gets the 0 volts to 12 volts and has a trigger input. The lamp is connected to live, and to turn it on you switch the other side to neutral, which just so happens to be the 12 volts. And it's switched with this triac. The trigger signal comes in through this 22k resistor, which limits the current from the passive infrared module, into this transistor, which then pulls the triac, which is referenced to the 12 volt neutral. It pulls it to 0 volts via this 2.2k resistor, and that's what turns it on. I'm guessing the 6.8 ohm resistor is just sort of inrush limiting, just to protect the triac more than anything else. The lamp itself is just, you know, it's like all the other lamps. It's got the capacitive dropper, 1 microfarad, which is quite a high value. That does elude, and I've already tested that, so, and it is, that instead of using multiple chip LEDs, they've just going for really high current through a small number of LEDs to get the intensity. I'm not sure where the capacitor is because I've not taken the heat shrink sleeving off that. I could just use a capacitance tester. I could just use this meter here, would probably test that right now. Not sure how accurate it will be because there is a discharge resistor, but it's quite a high value. Not even sure what the polarity is here. Could work it out. 20.6, let's test it round the other way. Let's say 22 microfarad. So yeah, just a typical lamp circuit with two 470k discharge resistor across the dropper capacitor and a 470k discharge resistor across this capacitor, which also serves to shunt the LEDs down a wee bit if there's any leakage current. So yeah, it's interesting, it works. It's a different approach to the other one, but similar as well. But yeah, it's a neat enough lamp.